So kind of picking up from where we left off yesterday, we kind of ended yesterday talking about the exercise, right? The group exercise. So everybody kind of went through that, and I think I've gotten a diagram from everybody. But I think maybe the place I would start is just kind of looking at showing you kind of how I would do this, the diagram that I would create for this. And we talked about some of the choices that I made in that process. Okay. So I'm going to pull over. Here's what my diagram would look like. Okay. And kind of a quick look. So I'd start by kind of laying out the entities, as I say. It's kind of the first thing I do. And I start adding in relationships. And where you start does kind of matter a little bit because it can make it easier to figure out where things go. You can obviously move things around later, but it's easy to start with a place where there's an anchor, right? And I think for this course, this particular exercise, easiest place to start is the teacher and the course, because those are pretty well anchored, and there's actually not a bunch of extra data to that. Like the teacher is connected to the course, and that's like the end of that relationship, right? Everything else belongs to the course, okay? So I'd start there. That's kind of the easiest place for me to anchor the chart. And that's good, okay? I can also say, if I'm talking about students as kind of a logical next step, I can say, well, students and courses are connected. If you look at that and you figure out, okay, that's a many relationship, you figure out you need a bridge table, as I think most of you can figure that out, right? So I say, well, I can't do many to many, let's put a table in the middle, okay? So I put a table in the middle, I'm going to call it course student. Sometimes I can come up with a better name than that because, slapping two names together isn't always the best, most readable name. You can also ask, should it be student course or should it be course student? The answer is it could be either. It doesn't really matter which order you put them in. I usually just take the one that flows off the tongue the best, but there's a lot of debate about what you should do there. Ideally, if I can find a better name for it, I'll take the better name, but sometimes that's not really an easy thing to do. And I don't know that in this case there's a necessarily better name in there. I mean, I could call this attends, I could call this member, that kind of thing, but then that easily gets overloaded, right? Maybe I have it a course member or something like that. You might call it something in that sense. Okay, so looking at multiplicities, you can kind of see, okay, I'm saying there's 1 to 20 over here, so I'm saying there's up to usually about 20 students in a course. In reality, it could be more. I'm not usually very tight about those limits, but it can be helpful to kind of give you a rough idea of what that is. Sometimes those upper limits, say 20, is an actual design thing, depending on who's making the diagram. They mean that as a hard limit, saying that there can never be more than 20 students in a course. I generally mean that as a soft limit when I'm writing that. It's like, this is what it usually is, but it could really be. It could be that maybe there's a 100 person class in here. Well, I'm probably going to plan for that, and maybe I should make that 1 to 100, but I'm saying kind of that's what I expect. So it's worth noting that those numbers, I don't usually actually do anything within my code. I just use them as a way to kind of think about how I'm going to structure things and where I'm going to put things. When I go to actually make the columns and the tables and how to break things out. But those are numbers I'm not actually going to put in code anywhere. Cool? Which is why I treat them as soft limits. Okay. I could now say, on the flip side, we're saying the student has up to 5 courses, right? In reality, it could be more, but there's a limit to how much you can fit into your schedule, right? And be able to do all the work. So we kind of say that's the part that I think a lot of people got, mainly because it was kind of on the slides. So that part you kind of got for free. I think the part that people struggled with is where do assignments and grades fit in that, right? And so obviously an assignment is connected to a course. That's kind of the easiest one to figure out, right? You've got a course, you've got assignments for it that you need to complete. But the question is, are you talking about, first of all, are you talking about the assignment as the instructor posts it, or are you talking about the assignment as the student turns it in, right? Because those are two different things, right? Is it the submission of the assignment, or is it the actual project, the lab, the specs for that assignment? And so I would define that as, this is the specification. This is the thing you see on inside Ranken. I create an assignment, and then you complete the assignment, right? So that's where I consider that. And I say, well, okay, courses can have a lot of assignments. We need to really make space for that. And I'll say, let's make space for up to 200 assignments per course. Because I figure, just rough ballparking it, if you say, hey, we've got an 80-day course, sometimes there's 2 assignments per day, depending on who the instructor is and depending on how we run that. So that puts you maybe at 160, and let's just round it up to 200 to keep the number square. It's really there to indicate that this, right, there's going to be a lot of assignments relative to the other 4 tables on the top. Does that make sense? That's really to tell me that, oh, okay, I really have to be careful about performance when I'm dealing with assignments because there's going to be a lot of them potentially. Does that make sense? So it changes how I think about how I optimize the database. Because I know that there's going to be a lot of those things, but not very many to think about. Okay. So there's different approaches you can take, and some of them are good when you have low numbers, and not so good when you have a lot of things. Okay. But by virtue of that being the assignment that's there, it can't inherently have the grade on it, right? So the grade has to go somewhere else, right? Well, can I put the grade over on the student? Well, I mean, the student at the end of the day, do they have one grade? What kind of grades do you get?
Assignment grade and class grade.
Is that the only 2 grades you get?
Test grade, exam grade, quiz grade, sure. They're all assignments, right?
Does the college also give you a grade? And then there's a GPA?
Yeah.
Right? So actually, if you have a grade up on the student, that grade would be their GPA. That would say, over all the courses that you've had, what's your grade point average, right? So that would be student specific. If I'm talking on a per course basis, well, I still can't even do that here because different students have different grades, right? So it kind of ends up having to be, if I'm talking about GPA, it would go into the student table. If I'm talking relative to the course and the student, the intersection of those two, I would put that on the course student table. And then if I'm talking about an assignment, well, I need a separate table for that entirely to connect all of that. And so realistically, if this course student represents somebody being in a course, will inherently have to be in the course for you to get a grade for an assignment, which is why I connect those. Does that make sense? So what I'm saying is here is by connecting it that way, I'm saying that you can't submit an assignment unless you're already part of the course. Does that make sense? Yeah, I could have taken this and connected the assignment grade. Well, it's like, okay, connect it to the student and connect it to the course, but then you can get a grade for a course that you're not part of. Do you see the problem? So one of the things that we're trying to do, remember, we're trying to make the data as accurate as possible, where we don't want to allow for anomalies. We don't want to allow for things that shouldn't happen. Does that make sense? Like somebody getting a grade for a course that they're not part of. So that's one thing to consider as you're writing these diagrams and thinking about the relationships, is you're allowing certain things to happen or not happen based on where you draw those lines. Make sense? Or how you break up the tables. So here I'm saying, okay, I have got those connections. So an assignment grade goes with an assignment, and it goes with a course student. Okay. Every grade you get goes with the student and course that submitted it, with the course that they went through, and submitted it for, and the assignment they did. Now notice the multiplicities and notice the directions here, right? So I say this assignment goes with 1 to 20 assignment grades. Why do I say 1 to 20?
Because there's only 25.
So because I'm saying there's about 20 students per course, right? So for every assignment, I should be getting about 20 grades. Does that make sense? In reality, how many assignment grades are there actually?
2,000.
About 2,000, right? What did you have your hand raised for?
I was going to ask why you have 1 to 200 for course-student relationship.
For this, well, it's the same idea. So here we have, right, notice that at the above, I have 1 to 20, I have 1 to 20 there. Because for every assignment, I'm grading it for each student. For every student, I'm grading it for every assignment. So this number and that number actually should be the same.
So it's not 20 times 200 for that.
Right. It's what is the relationship from one of these things to X of the other thing, right? So from one student, there's 200 grades. From one assignment, there's 20 grades. In combination, yes, there's 2,000 of them. So those numbers don't represent how many entities there are in the table. It just relative to something else, how many there are there, right? It's kind of multiplicative in that sense. That makes sense? And you can kind of see that if I go both of these pathways, 200 times 20 gives me 2,000. 20 times 200 gives me 2,000. So either way I get there, to the assignment grade, I get 2,000. That makes sense. Cool? So that's how I would set up the relationships, right? And that's all I would do first, right? Because that's the easiest version of the diagram to move around and figure out all your things. And then later I can come back and say, once we've agreed, and I could even give this to other members on the team and say, am I right? Do I have this correct before we go on to the next phase, right? Because even at this point, you can tell if there's errors or not. Make sense? So now I come back and I say, okay, that's what we're going with. I'm going to add in some attributes. And so we'll make it look like this once I get done with this process. So I start going through the tables, and I say, well, what data do I need to keep track of for each person, for each thing? So I say, okay, the teacher. Well, obviously he needs ID. I'm just going to call that an ID column. Add that in there. That's the primary key. I'm going to say, let's store his name as given name and family name. Okay. Now, I think I've told some people already about why that is. You know, why do I choose those? I think the summer course we talked about that a little bit. Oftentimes, another way that you'll see this listed is last name and first name, right? Okay. So at least in the U.S., right, when we're talking about somebody's first name, we're talking about their given name, right? We're talking about the first name in America, at least, is usually the one that you're given to by your parents, right? Versus the last name is generally one that comes from your lineage, right? From your family. Does that make sense? That's not true globally, right? And so sometimes that can lead to some misunderstandings. And so that's one of the reasons that it's usually considered, at least in some cases, better practice to do it this way. Does that make sense?
So instead of having like two fields for like first name, last name, just one where it stores their name essentially?
No, I don't have one field. How many fields do I have there? I still have two. I've just named them something different, right? I've named them given name and I've named them family, right? So that means, you know, your given name, regardless of your culture, you have a given name, a name that your parents have given you. For some people, that's their first name. For some people, that's their last name. or family name you have that is may or may not be that may or may not be your first name. That might be your last name or your first, depending again where you're from. Does that make sense? So that's kind of one of those things when we're dealing with internationalization, we call it, dealing with different cultures. You want to write software that works not just in America, but works across the globe. That's one way to deal with it.
So, out in like the industry, so essentially like we're working with software that's mostly for the States, is it still going to be probably first name, last name? Because we are working on a bigger scale, obviously.
So, that's a good question. More than likely, if you're working with a US company, they probably have chosen to do first and last name. For two reasons. A, they don't understand that there's other countries besides the US and that they do things differently. And B, some of them don't actually care. That's what it comes down to. So there may be some companies that have switched over to given name and family name and are doing it that way. A lot of companies you work with are still going to probably be listing it as first name and last name. Okay, but recognize those differences are there. And again, if you're trying to write it in a way that really handles all cultures, that's generally better. The other thing you have to realize in there is that even if you're building for an American customer base, right? What's the percentage of Americans that are actually from America?
50, 70%.
I don't know what the actual number is, but let's say it's 80%. Then you're missing out on 20% of your market. You're missing out on 20% of your customers. We're treating them incorrectly because you haven't thought about them. Because regardless of what country you're in, you're actually usually representing multiple countries, right, within that same country. Does that make sense? It's one of the reasons I suggest doing it that way. You can do that as first name and last family name, but I think that works a little bit better. One of the things that lets you do, I think India and China are the two ones that flip them, if I remember right, the two that I know about. And so it's a lot easier to know what to call somebody, right, if you know which one's the given name. Does that make sense? Because otherwise you get confused and like I call you by your last name accidentally, and it just doesn't work right, if that makes sense. So that's why I'm setting up that way. In reality, there'd be definitely more data in there, but that's just a start, right? So the basics, like for sure I need to know the name of the person. There may be other things, but I definitely need to know. Similar with the student, I've taken the same approach. So they've got a given name and a last name. Again, they doing have more information in there, but that's the minimum amount of information that I need. Okay. And so depending on if I got more requirements about what we're doing, I might have an expected graduation or GPA that I need to track or this or that. The actual fields that you have really depends on who you're building it for and why you're building it, right? And so that can change it. Like if I'm doing this for Inside Ranken, maybe I don't need a GPA. If I'm doing this for transcripts, student transcripts that I'm going to send between different colleges, then I definitely need a GPA.
Do we not need a teacher ID for course?
I forgot it. I need to add it.
I want to make sure.
Yeah. That one is missing. I will add that one in. So talking to about the course, so that's right, I need a foreign key for that because there's a relationship there. So I've got an ID to uniquely identify the course. It's worth knowing that course ID isn't actually the course ID that maybe you're thinking about. Like, so if we're talking about our course, right, we've got AWD 111, and it's database-driven web development, okay? In there, what is the name of the course? Is that the whole name of the course? Okay. It's not. So the whole name of the course is AWD 111. And actually on Inside Ranken, it's LO1, Lab 1, because it's the first section. And then that is actually the whole course name. Okay. All of that is the course name. Okay. Sometimes you get these confusion, especially when you're talking about talking with non-developers. They would say that the course ID is AWD 111, right? But it can't be that because AWD 111 is not unique. Why is that not unique?
You could have like different sections.
Right? Like we've got one section here in St. Louis, and we've got another section that's being run in Wentzville right now. And so this one's Lab 1 and that one's Lab 31. What else? Have I run this course before? Did it have the same course number? Yeah, it did, right? Last several times I've run this course, it's AWD 111, right? So that's not a unique identifier because you have different sections and you have different semesters together, right? So that can't be the primary key, right? So when I talk about the ID of the course, that's none of those things. Does that make sense? It's none of those things. In fact, more than likely, the way I'm going to set this up is the first course that gets added is course 1. And the next section that gets added is course 2. And then when that runs again, next fall, it'll be 3 and 4, and then 5 and 6, et cetera, et cetera, et cetera. So that number, that ID, generally corresponds to nothing in the real world. Does that make sense? Sometimes it may, but more often than not, it doesn't have anything to do with what your users are going to call the ID. Does that make sense?
So would you have a foreign key and assignment?
So a foreign key and assignment. How did I miss that one too? You're right. Okay. So that's how I would set that up. And so just the point there being is the ID is something arbitrary. It has no correlation to the real world. And in general is not something you're going to see in the UI at all, right? So course ID is something that's completely internal to the work system. Walking back over to the course student, right? So that's also going to have this arbitrary ID, just so I can uniquely identify those records later. It's going to have the course ID and the student as foreign keys because I need to know what am I joining together, what am I bringing together on both sides. So this is a combination of the course and the student. And you'll also notice that I have a course grade on there, right? Now specifically I'm putting that on that table because any linkage of the student being in the course needs to really only have one grade. Does that make sense? If you break it off into another table, you're inherently saying that a student can have multiple grades at the end of the semester. Does that make sense? At the end of the semester, when it goes on your transcript, you'll get one grade. And so that's very important that this goes on here and not on a separate table. If it was a separate table, you'd have to figure out how to enforce a one-to-one relationship with it. Okay. Make sense? So sometimes you have to be very careful about, sometimes things need to be broken out into separate tables, and sometimes they really cannot be broken out into separate tables. And that course grade is one of the cases. You can't have a course grade table. Going down to assignments. Okay, so ID, yeah, that makes sense. Remember, this assignment ID is not something you see. Course ID is something that's going to be say what course it belongs to. You've got the name of it, and then maybe I have a due date. Right, so a date that would be some sort of date object or a date time object. Okay. So going to the assignment grade, that's then kind of that connection. We've got, I need to know the course and the student. I need to know which assignment it's part of. and I need the submission date, and I need the grade. Okay, so like when did they submit it and what grade did they get? Okay. Now, there is one thing I would say is kind of interesting about the relationships and the way that I've done these form keys, right? Does anybody notice something sort of unusual with that table?
Which thing?
The assignment grade. Is there anything weird about that table that doesn't reflect stuff we've talked about?
It doesn't have a foreign key for course students.
Right. It doesn't have a foreign key for course student, but it does have a foreign key for course and student. Okay. Is that the same thing? Are those equivalent?
Because I mean, you could still technically get to for student following cues.
Okay.
I'm gonna say it's not the same thing.
Okay.
Because if it was the time that one is looked at any assignment grade and looked at its course student ID,
Mm-hmm.
and we went to that course student ID,
Mm-hmm.
we would only have one entity.
Okay.
But if we had hooked up to a student and a course,
Mm-hmm.
we could get all of the information from the student course.
So let's try an example here. So you're kind of on the right track. It's not exactly the same thing, but it should be. Okay, there's the distinction. It's not the same thing, but in this case particularly, it really does need to be true. Okay? Does that make sense? Okay. Now we haven't talked about how to force that to be true, but I do need to force it to be true. Okay? So let me show you why this would be different. Okay? So why would this be different? Let's say I have AWD 111 here, and let's say for argument's sake, let's say the ID of this is 5. Okay? And then I've got a student over here. We get a volunteer, Parker. Okay, so Parker, your student ID today is 77. Okay? So these are unique things, right? At least they should be, right? I should only have one Parker in my student table. I should only have one copy of this semester, this section's AWD 1, right? Now what happens if here in the middle I have two records, one that says 577 and another record that says 577 in the course student table?
That wouldn't be possible.
But this schema allows that to happen. I haven't prevented that. I haven't said that that's impossible. The schema doesn't stop it from happening. What would that mean? If I were to think about how that might end up looking on the UI, well, that would mean that Parker shows up on my roster twice. Does that make sense? That would put the same student in the course multiple times. Does that make sense? You kind of see the problem? So you see why I want to not allow that to happen. You see? So I don't want this to occur. But if this does occur, right, then I could then have an assignment grade down here which says 577 and says he's getting an A. But does that go to this student or that student? Right? You've got 1 and 2, right? I don't know which course student record it goes back to because I didn't store the course student record.
So how does that database react that in the first match it finds it applies whatever you want to do?
It all depends on how you write the code. All depends on how you write the code. more than likely what's going to happen is throughout your process, you're going to see 2 copies of the same student. And more than likely, they're both going to end up with a name. Does that make sense? This does allow that to happen, right? This does allow that to happen, and it doesn't keep track of that. But I'm okay with that. I'm okay with that because realistically, first of all, I don't want the same student in my course twice, on my roster twice. So I don't really care about treating that case down here. And I don't want them to have different grades, right? Does that make sense? If that does happen, I do still want them to have the same grade, okay? So I do want to prevent this, okay? We'll talk about unique constraints. Unique constraints is how you keep that from happening up there. But that's part of why I'm doing this choice. Does that make sense? It's going to tie in with how I'm going to make these things unique. Cool? Okay. So that's where that fits in. And so technically what I'm going to do when I set up my foreign key here, foreign keys can actually refer to not just one column. It's worth noting. A foreign key can actually refer to multiple columns within another table. So when I set up the foreign key here, I'm actually going to say both course ID and student ID are a foreign key into a record and course student. And I say these 2 columns match up to 2 columns over there. Most of these, I'm saying, well, this assignment ID is a 101. There's one assignment ID, there's one assignment ID. But there are cases like this, you may match multiple columns in one table to multiple columns in another table. Does that make sense? So this is kind of the, there's a bunch of ways to go about this table down here, but this is the one that leads to the most efficiency because it also means I can easily query grades by courses, by students, or assignments. I don't have to go through that course student table because if I had the course student ID, then I would have a problem because I don't know, just looking at this table by itself, I don't know what course I'm talking about, I don't know what student I'm talking about. But this way I do know that. So it makes it a lot more efficient to query it, and it turns out it's going to make it a lot easier to avoid duplicate data. Okay? Remember, that's part of what we're trying to avoid. Part of what we're trying to avoid is duplicate data. Okay. Any questions about the schema, the ERD at this point? Does that make sense what I'm doing? Does that help kind of see where some of your diagrams might have gone off the rails in a few different places? Maybe? Okay. So, now that we've talked about that, let's get into the actual meat of today. Okay. So we talked about databases in the abstract yesterday. Okay. We went through them and kind of introduced you to the concepts, and you did homework on that as well. Okay. So our plan today is we're going to actually start working with databases in the concrete. Work with an actual database. Okay. So MySQL is what we're going to get started with first. Okay. And so that's what I'm talking about here. And so part of the process that we're working with is taking those ERDs that we made yesterday and turning them into an actual database. Okay, that's kind of our goal at the end of the day. So we're going to take your ERD diagram that we made yesterday and make a database out of that. Now, obviously, if you've got some issues with your diagram, you may have to go back to the diagram and fix those issues so that you can create the correct database. Does that make sense? So you may have to do that first. We're going to get into that. So first question is, what is MySQL? Okay, MySQL is not a language. Okay, SQL is a language, and that's the language that we use to generally talk to our relational databases. Okay, MySQL is what we call a DBMS, a database management system. It is software that actually manages the database files for us. Okay, so it's a kind of a collection of that software. And generally, when we're talking about the DBMS, we're talking about the server that you connect to. So a little bit about background about MySQL. MySQL's been around for a good amount of time. It's actually been created around 1995. So this database is actually about 25 years old at this point. When it launched and Since then, there's always been a free version of it available. It's been freely available for anybody to pull down and start using, with some licensing term that if you start using it to make money, you start using it for your business, then you might have to pay them something. But you can use it for free up until you're making money. Does that make sense? So that's been a really good entry point for a lot of people, a lot of developers, and a lot of people getting into the business, a lot of small business, non-for-profits. They've used this. In fact, most PHP websites that you see out there, PHP, WordPress, if you see that, more than likely, there's a MySQL database on the back end. Okay, so if you've ever heard about WordPress, 99% of WordPress sites are running against a MySQL database. So they're actually still pretty popular. They're originally created by a Swedish company known as MySQL AB. Like literally, this is the thing they did. In 2008, they were acquired by a company called Sun Microsystems. Okay, Sun Microsystems. So anybody heard that name before? What are they? Okay. What are they? Do you know what they're well known for? What do they sell?
Didn't they make like Java?
Yes. Yes. Sun Microsystems is the same company behind Java. Okay. Now MySQL is not built in Java, but they're the company that, Sun is the company that created Java, maintained Java historically, and then also, purchased this MySQL system in 2008. Sun Microsystem, their actual main business is in selling server hardware. In fact, they've been around long enough that they used to sell mainframes. Okay, originally selling mainframes, they now still sell. I think they're still, they were then going into server blades. They've also had a little bit of interaction with mobile and such, especially through Java, smartphones and such. We're talking pre-iPhone and pre-iPhone and pre-Android. They were involved in the smartphone market. But Sun Microsystems around 2010 got bought out by another big name in the industry named Oracle. Okay, so Oracle completely bought out Sun and everything that they have, including Java, including their server business, including MySQL. MySQL came along with that. I don't know really the reason that Oracle chose to buy Sun at that point. I'm going to guess, though, part of it is that they wanted MySQL, that they wanted that share of the database hardware, because MySQL and Oracle have competing products. Like Oracle has a long-standing SQL database project that they sell, and a lot of big companies historically used, and is one of the most expensive products, most expensive relational database on the market. It is really the most expensive one you can buy. But they market it as being the best one for large-scale business. Whether or not it's that, I don't know. I've never used that. But that's where it stands. So honestly, in 2010, a lot of us that were using MySQL at the time were kind of like, okay, now what do we do? Is Oracle going to keep this project around, or is it just going to die on the vine? And surprise, surprise, it still exists, but I don't know that it's seen much maintenance. Because obviously Oracle wants to spend their time on that. I know it's received some updates, but I think it's not seeing as much attention as Oracle is paying to the other projects. But it's still out there, it's still freely available. Okay. If you look at the Stack Overflow survey, the developer survey, it goes out on an annual basis. In 2020, it was actually at the top of the list. It's been at the top 5 for the past several years, but last year it was all the way up to the top because a lot of people were using it. I think WordPress has a lot to do with that because there's still a very high percentage of the market that's using WordPress to develop, websites and develop CMSs. I think that's part of what's driving that demand, but that's kind of where things sit, right? And so we try, at Ranken, we try to keep things up to date, and so that's one of the reasons that we, chose when you're looking at technologies and what to do, and decide what databases to teach you guys. That's part of what influences our decisions, is the results of the Stack Overflow surveys. So that's part of why we're covering it here. Plus, we know that connection between WordPress and MySQL is a pretty strong one. Okay, so what I want to do at this point, I want to get you to install the actual software that you're going to need to do this, because I do want to do a little bit of hands-on work with MySQL today. I already sent out some links on the Discord to ask you guys to try and install this yourselves. I know that it takes some time, so just want to try and do that now. Previous semester when I did this, I know that there's been some bumps in the road, so kind of be aware of this. It might be 30 minutes, an hour between now and when you get this all sorted out, okay? So just be patient. I'll be coming around and trying to help people work through the issues as you have them. Just recognize that there's usually some hiccups, depending on how your computer's set up and those kind of things. So.
It was asked in the Discord. Anything?
Yeah.
There too.
So I'm going to do this on my machine because I actually intentionally uninstalled MySQL so that I could show you what happens when I try to install it on my machine. So, but I'd asked people to do it simply because, you know, hey, things take a long time. So even if a few students get it done before we go over it, that makes overall the process go faster. So if you go out here, I'm on Windows, so I'm going to see this. Here's where I want to go to that installer. I think, Michael, you're on Mac, so you should be, where's the Mac OS? So you're going to see something like this. I'm going to guess for Mac as concerned, I think this is the one, either one of these I think you may want. Oh, ARM or x86. I don't know which one for you is going to be right on. But that's what you want to download and install. And so that's going to be a little bit different for you, but I think most of it's pretty self-explanatory. So back in the Windows world, I'm going to click on this. There's two different versions, and honestly, it doesn't matter which one you pick. Okay, one of them will be faster than the other. That's the only difference. Okay, so you see this one is 450 meg. This one's 2.4 meg. I'd probably go for this one. I'd probably go for the smaller one because that's probably going to be your faster download. Okay, so if you haven't already pulled it down, go ahead and pull that one down. It's going to ask you if you want to join Oracle. You don't need to do that. Just say no thanks and start the download. So again, you can really grab either one. If you went either way, it doesn't really make any difference. The only difference is how long it takes to install it. Because the smaller one requires an internet connection while you install it, but the larger one just requires an internet connection while you download the installer, not while you're running the installer. So depending on how fast your internet, or if you have internet available, that's the difference. Make sense? Okay, so if you looked at the details on one of those said it's the web installer, and the other one is the offline installer. Okay, so when I told this to run, I'm going to get a bunch of these prompts for admin access, and I just need to say yes to all of them. And it's popping up on my other screen because that's listed as my main screen. So let's fix that real quick. Okay, so when we get into here, okay, you see there's a bunch of options. Okay, there's a developer default, there's a server only, there's a client only, there's a full, there's a custom. So there's a lot of options, right? So custom lets you decide what pieces you want, bits and pieces you want to install yourself, gives you full control over that. Full is going to give you absolutely everything. This is going to take a really long time to install because full is pretty big. If you install just client, well, that means you have a server. I mean, you don't have a server. You don't have any place to put your data. So that only works if you have a database over here and you're only like just interfacing over here. So that's not really what we want. We do need both the server and the client. Okay. So in order to do that, I'm going to pick the developer default because it turns out the developer default has basically the stuff that we want for the average user. So I'm going to pick developer default. You get in here and it's going to say, hey, I want MySQL server and I want Workbench. Community server, this server is what's going to actually host the data. That's where the data is going to actually be stored. And it's worth noting that that server runs as long as your computer is up and running. Okay, so at some point you may actually want to uninstall that server so that you have your resources back to do development. But that's one thing that's there. The Workbench is a graphical user interface for working with MySQL. So we'll end up wanting both of those things installed. So fortunately, the developer default is going to go through and install both of those things for us. Okay, did you start the installer already? Okay. Go back. You choose, okay, go next. Okay. So it looks like you may have already have it in. Okay. We'll come back. I'll come back to you. Let me check where everything's at. Okay, connector. You're fine, we can keep going because we're not going to use Python. Yeah, you can go ahead and okay, that's fine. We're not going to use Python this way. Okay. When I develop my version, I want to make it my idea. I'm just going to have a translator. Oh, on what bench? Okay. I know. Okay, so you're going. You're going. Maybe you can make a shot now. Okay, that's fine. That's fine. We'll just need to install Workbench separately. Go back to yeah, you're on developer default. Okay, that's fine. Warning. Okay, so hit execute. That's probably why. Okay. So Adrian, you have kind of a weird case. So download the what? No, that's something completely different. This is asking about logging and creating an account there. No, no. So what this is saying is that you're missing Visual Studio. Saying Visual Studio 2015, 2017, or 2019 must be installed. And so you actually need to go install Visual Studio first. Okay. And so that is something you're going to have to fix. So before you can run this installer, this is the small version. Okay, so we're gonna have to restart the computer.
Yeah.
And when the computer restarts, try to run the MySQL installer again and then see if it shows the same. Okay, so it should be false. Okay, you may just have to try again. Okay, cancel.
Should I just restart? Yeah, go ahead and do it again. That was the last time. We should have Get that right there. Yeah.
Oh, you're right, though, about the installation. It's a long time.
Yeah. Okay. So what we need to do now is we have is already installed something.
Oh, so that's just a terabyte of external storage because
That means it's all.
yeah, it's like
That would be part of the problem.
okay, well we just
Right, so when you talk about there, that makes sense.
We actually get it out to the video. So you yeah.
well I actually did it like so
It just happens.
okay.
It doesn't matter what it's.
Yes. Anything, right?
It's not like.
Anything other than
Yeah.
Is it open to go to the function?
You have a computer. Your desktop.
So.
Yes. Desktop. So it's like sure about that.
Hey, I sent, a rule in my, rules. Original modification, and now they just want that.
Well, it's a cheat.
How much? Did you set it up? You gotta tell it you want it to, Attention, I was told that, and is like, that's how the video is done,
Especially when
so here's like, one phrase. Oh yeah, just go back to that and type of rule.
More on here. So what we can do today is try to install it on there. But it's gonna be more than installed. And install it.
will give you a box type into type in you and then Google lets it when it comes through. And then choose any type tool. And then it's self-explanatory. First box type in there is just to call and give the role to it doesn't actually title the inbox.
Okay.
From that action move to and I ran it otherwise all the thing up and sit there. And with this stop processing rule, I press click and I couldn't understand what the private thing was. That's why it's there. Just click it by default, I decided you don't want to do back to
Reading the code, I have that now. Yeah.
I got the thing I don't want Doesn't matter which one. But 517 was 2015. You said you weren't going to use it last time.
Thinking of it.
I think you probably could try this next and see if it works. But I think
Oh, but I don't.
the Python one though, the Python, that second one, I understand thing and
So let's go ahead and try it next on it. Yes. Actually, let's do one thing. Cancel. From his visual studio to control. Let's try and do Python. Everybody's having problems with not having Python installed too. So let's get that one down. So go ahead and install Python and then try to run this installer. If at that point it complains about those two things, just try to go ahead and install it and then stop at that screen process. The next screen. What's that mean about that?
It's not enough time today. When you find out commands and stuff, it's not enough time today. I was like so busy yesterday. Yeah,
very good. Unclear.
this was.
I look forward to the day when they're not teaching. That's what I do. I get to sleep. Or probably fun to have to work in with school. In fact, I would work 30 minutes early today so I can finish up my homework.
What's that?
I would work 30 minutes early today so you finish my homework.
Can you work overnight?
No, I work early. 5 days with just down the road from home, so I can start home 15 minutes. I got time to shower.
What time do you go to sleep? Can you have it?
I'm not ready to midnight before the wake up before the but yeah, those days, that's for school. But I don't have the right home because I'm not in crash. Yeah, I'm just thinking like driving the field. Really, stop getting home, be tired, all the way. Yeah, I'm practicing.
So tired.
No, you're right. What's your excuse?
That's ironic because it's not the same work. I like having money and not having people here. Already had that. Yeah, I was lucky though. My family's in Greece, so I actually just started driving. No, I wasn't even with anybody. I was driving too fast on the wet road early in the morning. Early in the morning on the way to work, and came to a curve going 55, should be going 55. Went off the curve a little bit. Ran into a little bit of like side gravel. That threw my car off. I turned back in the road.
Did you get someone else?
No, I ran into the bank. I was in a bank, like, like north side of the road, like this, and then a wall of dirt. It was country, so it's not really something that I went into the city.
I was on the highway. Come off the road. I was like, I think I was about 6.
What?
Yeah, so I just come in.
Yeah, you just go right out.
That was like real bad.
Damn. Yeah, it's scary, man. I've read people talk about hide your funding on the internet. It doesn't matter what car you have, what city you have. It doesn't take much. There are limits. Like rubber. Yeah. I blame it. People still be going fast. I'm not happy with it.
Show me okay, application.
I'm not sure what happened with my insurance when I got here. I don't think we looked. I don't know if you have to report it.
Did you file a claim?
The thing is, the car was totaled.
But did you like report it or did you just like pay for
But like, see, here's the difference. When police keep running with somebody, they're gonna report it, even if you don't. So your company's gonna find out no matter what.
Yeah.
But that ain't even happening with you. I don't think we told you. So my insurance ever went up.
That's alright.
Maybe, I don't know, it was like 4 years ago. It was 2017.
What I had, I was trying to figure out who I talked to him. I said, you need to report how much like fix going on. So you make a claim. They said the car was totaled, like, what do you do?
Right. That's what happened to me. There was just a little dent in the body panel, and the mirror was going, but still, the car drove. It's still going to work.
It didn't take much to tell it apart.
And I'm thinking, but the worst part was when I've been there, I don't know, like years ago, my one that felt like that was bad.
I don't know.
All I was doing was sitting in the car. I spun once. I spun 180 degrees. And it felt like I was going to die. When I hit the wall, the car came up to the wall. I mean, I didn't point or anything, but dude, it was so loud. It was the loudest thing I ever heard.
I wasn't even scared when I did it. I walked around there.
Caught me off guard. Anyway, tell my kids. All my units.
You still drive there?
Only when it's safe. You know, like under highway but it's not really very
I used to drive the
That's
I don't do it. I don't do it.
I'm more concerned about the hour management. I'm trying to take a class. I'm trying to be careful.
I figure it out.
Not that I'm trying to exercise or anything. That's kind of a lot of
Speed for my
not too fast. Plus, you know, I like conservative fuel too. So that's why I keep it steady and not drive too fast.
That's why I say that.
But it's tough. When I think this year, dude, people man, they are just aggressive. And then there's traffic everywhere. You stop at Starville County.
You want to
accidents.
You want to experience it? It's really like the top state when it comes to like drivers.
Really?
It's like one of the better states.
I don't doubt that at all. Because I hear some bad stories about other states.
So I had my menu, but I don't do it.
We had an Uber driver take us into Florida. Like, we were trying to Thompson Beach. And dude, that Uber driver drove like a day.
Still works.
Yeah.
No, because it already installed with that's already. And we don't need to cause additional problems with it by trying to do two things at the same time. Okay. So some people are at this place already, so I'm going to go ahead. I think I all got all but a few here. Oh, I guess I still need to do this. Most of you are on a screen where it says network setup. Because how many, just by a show of hands, how many people have got on network setup? Okay. So if you're looking at network setup, it says a few things, right? You see at the top, you've got a drop down. It says config type is development computer. Okay, so if you look at the options in the drop down, that's going to kind of tell you how you set it up. It's pre-selected development. So a few people already blasted through this. that's okay. Okay, that's okay. Development computer just says, hey, I want to set this computer up as a machine that I'm going to write code on. Okay. The big server computer is going to try and set it up as if that was a server, like we were going to actually run a production scale app, which we don't really want. And it says dedicated computer, that'd be similar to that as well. So development computer is the one, which is that first option. Okay, so if you already did this, it's going to be. But there are some things I wanted to kind of call to your attention. I was hoping to have them up here, but it's my install still going. So when you're looking at that screen, you're going to see, in fact, if you know what I can do, I'll just wait for this to go. If you're looking at that screen, what you're going to see is two pieces of information that are important. Anytime you want to connect to a database in general, doesn't matter what database it is, you need two pieces of information. You need to know what computer it's running on and what port it's on. Okay, what computer it's on and what port it's on. Okay, and so that may be the computer that it's on, may be the name of the computer. Okay, like it may be Paul's computer, it may be Paul's laptop, it may be Paul's desktop, or whatever that may be. Or specifically you're referring to a domain on the internet, more than likely you're going to have a domain name to get access to that, or an IP address of some sort. Does that make sense? So the good news is, because we're just connecting to a server on our own computer, and this works whatever you're doing, our local computer goes by a few different names. Okay, so localhost is you can use as the name of your computer. That refers to yourself. If you need an IP address, you can also do 127.0.1. Okay, both of those refer to your computer itself. Okay, you can also, if you're working with IP6 addresses, we kind of mentioned this yesterday, is ::1. All three of those refer to your computer itself. So any database server that you're running, any web server that you're running in a development environment, you're trying to test it on your computer, that's going to be the name of the server. You can use any one of those three names. Okay, and so localhost is generally the one we use. Does that make sense to everybody? Often this is known, if you want to remember, this is known as the loopback adapter, because it loops back to your own computer. Okay. So that's how you're going to refer to it. So that's the first piece of information. You need to know what computer you're connecting to, where the server is. The next question to know is what the port number is. Okay? And so if you're looking here, I think you should see that the port number is pre-filled in as 3306. You see that? Port 3306. What's that? Are you looking for 2205 or 205? Miss, huh? Oh, go upstairs. We'll check the offices upstairs. That's one. Okay. So that's the port number if you're looking at the UI. I think I can finally go to the next screen so everybody can see what I'm looking at. There it is. So this is what we're talking about. So config type is this. If I was setting this up on a server, I would be setting up a server computer, but because I'm doing it locally for development, that's it. So TCP/IP is going to use port 3306. Note that you can change that there, right? And if you change that, then when you actually write your applications or trying to use your code, trying to use Workbench, you're going to have to put that different port in because it's going to assume that 30306 is the port of that computer. Oftentimes for security purposes, we will change that port. If we're using a real server, we're going to change that port so people can't just guess where it is. Or they can't just know, oh, I'll test 306. Oh, it talks to me. Well, that means MySQL is installed. Because every different DBMS uses a different port, right? So if you know that it's MySQL, it's probably going to be 0306. And by virtue of that, if it's 3306, it's probably also MySQL. Okay, so for a development environment, that doesn't matter. The security on the development environment, that doesn't matter, but it really does matter when you're setting up a database server. Does that make sense? Okay. So that's what we need to write down. So if you're trying to work with MySQL, make sure you memorize that as port 30306. That's gonna be one of those things I often have to look at. I think nowadays that it pre-fills it, it defaults it, so you don't necessarily have to remember that. But oftentimes you may find yourself putting that port number in your code or into the GUI that you use to work with the database. All clear? Okay. So when you get to Mongo, Mongo will have a different default port. It won't be 3306, it'll be a different number. There's some other ways to communicate here, name pipe, shared memory. We're not going to worry about that because this is the kind of the one that we want. Okay. So use strong password authentication for that, or use legacy authentication method. The top one is the stronger one. I am actually going to use the bottom one because it tends to have fewer bugs, at least right now. So I'm going to click use legacy authentication method. Okay. So when I get into here, it's going to ask you to do pick your current root password. Okay. For everybody here, okay, is there anybody here who has gone past this and has set or actually, let me ask you two questions. First of all, by show of hands, who's at this screen? Okay, so I have 1, 2, 3, just 3? Okay. Oh, I know why mine is different. I'm going to have to fix mine because mine is because I've installed it previously. Okay. So you have one that's asking for the root password and to repeat the password. Okay, so you got 2 fields for the password, you've got 2 fields for the password, 2 fields for the password. So that's just because you've never installed it. So that's fine. You just asking for the password. Installed it, uninstalled it, uninstalled it. That's okay. So this part's kind of important. So it's asking you for this root password. Most of you have 2 fields there. That root password is something that's really hard to change later. Okay, so absolutely make sure that it's something you can remember. Okay, there is a way, and I have a script that I pulled out to do that because I have forgotten my root password on this machine a few times. But it's just hard to do. Okay. It's not an easy thing to change that password if you forget it. So definitely pick something out that you can remember. I would, in general, when you're picking these things, especially for a development machine, don't pick something that you don't want to see have your instructor see, because more than likely you're going to end up needing to put it in your code somewhere. Okay. So, good news is it doesn't have to be incredibly secure. It doesn't have to be a terribly good password because we're not going to be really connected in that place. Right? It's just for your local machine. Cool. So go ahead and pick password and enter the same password in both of these fields. That's okay.
So should we consider the future? I think we might use our computers for more secure purposes in the future. You say it's difficult to change it. Should we choose something that's future password that's useful in the future?
This is a weird one. I would not really recommend using the same one that you log in with, honestly.
Should we put ignore this bottom part of the
Yeah, you don't need to do anything with that right now. So you can just hit next. Once you've got that mouse. So, okay, so this next thing, let me explain this a little bit. So this screen, it's asking you, again, I think a few people have gone through this and taken the defaults, and that's pretty much it. But it's worth knowing about what's happening here. So this is asking about a Windows service. Okay, so Windows service is something that runs all the time, runs in the background even when programs aren't running. Okay, it's a way to run code on Windows without having you actually start up the program. Okay, so a lot of programs use this. This is how the database is going to run, ideally without you needing to start it. So it's going to say every time you boot up your computer, it's going to start the server. Does that make sense? Unfortunately, that will make your computer booting up a little bit slower. I can say that as well. I can see that for sure. I've also had some students in the past, sometimes this doesn't start at startup. I've had some issues where sometimes it starts for startup at them, and sometimes it doesn't. So sometimes we've had to troubleshoot that and start the service manually. Okay, so I'm going to leave the defaults, but just know that that's what this is about. This is about making sure that it starts every time your computer boots, and this is oftentimes something we have to troubleshoot. Options that are here, you can say don't set up a Windows service. If you don't set up a Windows service, you'll have to start it manually via the command line. If you don't check this box, it will create the service, but it won't start it automatically when the computer starts. So if you don't check that box, your computer will boot up just as fast as it has been previously, but you'll have to go manually start the server anytime you want to use MySQL. Does that make sense? Okay, so that's just some considerations there. There's also standard system account that says it's going to basically run as like an administrator sort of thing. Not exactly because it doesn't have administrator permissions, but it's going to run system-wide. Versus you can set up for better security, you can run it under a specific user. And this is oftentimes what we do to isolate our database. That's a pretty important thing in terms of security, is to have it running on a different user and not running on the same user that we're doing other things with. So I'm going to leave that there. Develop machine. Okay. So we're going to hit that. I'm going to hit execute. It's going to run through here, and I think we should be done. So just checking real quick where everybody's at.
Yeah.
Go ahead and see that. Scan this one. Yep, 4.6. And we want to check that box. Yeah, 14.46. Okay. All right. Okay. So, all right. So I'm going to hit next on this screen. Anybody that's following along. Okay. It's going to say set up the MySQL router. We don't need to do anything with that, so I'm going to just leave it alone. It's unchecked, so it's not going to install it. Next, connect to server. Okay. So now you can see it's asking me for that root password that we entered previously. So I'm going to do that. Check it. It says yes. Good. I'm going to go ahead and execute. This part, what it's doing is creating a sample database that we can use. We're going to use this for labs to, this week and tomorrow. So if that's all good, hit finish, and hit next, and we're going to hit finish here. Okay. So it's pulling up the shell here. I don't need to do anything with the shell, so I'm going to go ahead and close it. But I'm going to go pull over to MySQL Workbench. Okay. So here's where we want to be. So we should have Workbench installed. Good news is that installer had both of these two things in there. Workbench, again, is the GUI kind of part of MySQL. Okay, so this gives us a graphical interface to work with. So we're going to hit that to log in, and you should get into something like this. And I've already done some stuff, so I've got that open. Okay, so I'm going to check that everybody's kind of at the same place. Okay, you're showing management. Okay. On the left here, there's two tabs. Okay, so there's an administration tab and there's a schema tab. Everybody see that? When you started, it'll probably be in the administration tab. Over here, you'll be in the schema tab. Okay, so most of the work we do with this is actually we're going to make sure that we're in the schema tab. Schema tab is where we're going to do most of our work. The one thing that you can do under administration, and this is often helpful when you're doing web development, is you can work with users and privileges. And let me walk you through that real quick. So just go out and get back onto administration if you haven't yet, and click here on users and privileges. Okay, so what you can see here, actually, because I've done something previously, is you can see I've got some accounts set up, an admin and a cowboy. I'm going to actually go ahead and delete those users. So I'm back at the same place where yours at. Does everybody have the same users as I have on screen now? Does anybody have something different? Okay. So what we have in here is a root. Okay, we have that root user. That's what you're using to log in. In general, that root user, you really want to reserve that for your database administrator. So generally, your database administrator should be the only one that ever uses that root account, or occasionally you as a developer. You never want to actually run your code against that root account. Does that make sense? The root account has some very special permissions, way more permissions than you ever want your actual user account to have. In fact, you can't constrain the permissions that root has. The root has can do anything. Okay, so what we often need to do is add another account. And so let's say, hey, this is my application, right? I might say this is my app, right? I might create a nice user here, call it my app. I can choose what kind of authentication. I'm going to leave it as standard. Limit to hosts matching blah. And so it says, what host can you be on to connect to the database? And percent means anywhere. I can connect to this from anywhere. So I'm going to create my app. I'm going to pick a password. I'm going to confirm that password. Okay. And so if I hit apply now, you see I've now created my app user, right? And so I could constrain, whether that's a developer or whether that's an application that I'm writing, I could constrain what that user has access to. So I'd be using those login credentials, that username and password, to connect to in my actual application. Everybody's kind of following along with that? Okay. So right now, this user that we've created can't actually do anything. They can log into the database, but they can't do anything from that point on, because just creating a user doesn't give it any permissions, much of any, besides just being able to log in. So what I actually want to go to is take a look at some of these other tabs. Okay, so there's like some account limits. Account limit says there's a limit on how much SQL it can run, right? So right now it's not limited at all. It can run as many queries as it wants, as often as it wants, how many updates, connections, concurrent connections, etc. That's a good thing to limit how much resource your application can use so that it's not going above and beyond. Unfortunately, it's really hard to know what those limits should be, but you can use that as one thing. Or you can use that as ways to say, hey, this developer, somebody in your company is really slowing down your database. Well, at least you can put some stuff in there to limit how much they can do. Okay, but that's not really what we're here for. I can go over to administrative roles. Okay, so these administrative roles gives you a way to kind of give a set of permissions to different groups of people, and this gives them permission to all of the databases that are on this computer. Okay, so they'll have those permissions on every single database that exists, which is great if you're trying to bring on a developer, right? If I'm trying to bring on a developer to this database and I want them to have some permissions to kind of work with it, I often would give them one of these roles, okay? If you want to give them free reign to do anything, you check the DBA box and you hit apply, and now they can do absolutely anything you want in the database, if that's what you need. Does that make sense? That's the way to give them everything. Without checking that box, they can't really do much of anything, but that way they can do everything. So that's the simplest version of that. That's the simplest version of that. And so especially if you're dealing with some sort of development database, sometimes that's the easiest way to just set things up. Say, hey, you have a DBA role. You can do everything. I trust you. Don't break anything, please. But it doesn't really block them from doing anything. The other side of things you can do is you can go over to the Schema Privileges, and if you're in the Schema Privileges, this is where you can be really fine-grained and say they can do this and they can't do this, and they can do this and they can't do that. So if you're trying to set up an application and limit what they can do, generally we're going to give them credentials here, privileges here. Does that make sense? Schema in the SQL world, in MySQL, is basically the same thing as a database. Database and a schema are kind of the same idea. They just call it schema. Okay. So if we had a database already created, I could come in here and say, well, that user only has access to this one database. Does that make sense? Okay. So now that we've got our tools installed, and that working, one of the next things we want to do is actually create a database and see how we go through that process. Okay, so I've got some slides. I want to go through that. I do think that maybe now's a good time to take a break because the next bit we're going to be kind of rolling with. So let's go ahead. If you're at this point, you're at where I'm at, you can see users and all of this. Go ahead and take a 20-minute break and come back at 2:20. If you're not here, if you don't have everything working, I need you to hang around and we're going to try and hammer the last bits out to make sure that you're up to speed. Okay?
2:30? Okay, 20 minutes.
Yeah, 2:30. Only if you're done. Right? So, okay, you're here. So you're good. You're good. Oh, you do want to create that. I'm sorry. Well, I do because I had a phone on, so what I need to do. So, you're going to go to add account. And then we're going to call this like it's my account.
What are we doing? It's obviously a good job, huh?
You're going to make a big round.
No, it's not good. It's better, huh?
Yes, baby. Come on, dude.
Obviously, it's not even better, right? We had a bunch of concepts. Great job.
doing the easiest part. So you always see somebody getting there and figure out like, yeah, everyone's like that now.
I don't know.
See how he's doing there? Yeah. Now you can go one world. So. What's eating it? Yeah. What is it?
I mean, this one, it seems to be going around and fairly hard working. Pacing does matter.
So you're
Right.
go to your so I was just looking at that.
So you're not going to be able to do anything. Like you're not going to be able to do anything from this. It's 35 baby and make it bigger. Can't do that. So,
Where is the
because it's not allocated. Because so like everything in here doesn't matter. Okay. So here you can only solve it by
The thing is, there used to be like I used to write out one, used to go and just like switch back like right away. But like I'm not.
Yeah, then maybe this is an old mindset that full of chance and just put that as
Oh,
I never read Java.
oh yes, and you can like right on it. It doesn't think about it. That is absolutely. You go on the people that there's gold nuggets and you can grab those.
You have to go to these.
Yeah.
oh,
Like so I'm this basically but I'll be late. Just any literally it's like a hard fail. Yeah.
I was gonna do restart and update.
Yeah, like I'll have a main problem. I already filled it right.
Yeah, that's it.
that's all.
Yeah.
That's not promising. Okay. What are the English icon? Power. We're going to try it. Maybe something. This thing goes back to default.
Yeah. And
Yes. You know, and solve. That's wrong line.
right, me too.
So, you can't get that. This one? Is this stuff?
Anything you have to say how many years from now, I would put this on how I want that. I bet. It's only just like just the like
Yeah. I mean, honestly, it's really not that big of an issue anyways. I don't really have that much on here.
it's what you do with the 10 times. So there's the problem is that
Maybe it's your.
I don't know, that's how it complicated. And so I think the problem with default is very high. I don't very that's not enough. That's what that's the tips.
Right.
Yes, well, this is very rarely. I had a guy took like 8 bucks and all 1 hour. They literally put in a stack for $1 points. Yes.
I got people who trade minimum gas off, doing one or two things. Either trying to work on that, set up.
I make things. I said out there.
Yeah, that'll probably work for us. I just like work for most days. Like, send the file over to me. I mean, I'll be honest. Like, like I did pretty much like everything on my desktop, and this is kind of all I'm working with on my Mac. Pretty much. I tried doing like boot camp because I figured I was like, well, when Mac isn't the best thing.
If you take it to the Apple Store and this doesn't work after the starting this, when you do that, I would recommend not having
Yeah, I saw pretty stuff in it and stuff, so I was like, yeah, like I said, the only reason why I did put that is just like explain that kind of like natural, like the referable, like way of like things out, like my things on the stage where I go in and use that option, but that's pretty
So,
So then, Parker, I'd ask you to just, Parker, I'd ask you to just at this point sit with one user you work with Chase. So you guys just pair up right now. For now. I think that's it.
Why do you got that? I did. Really enjoyable.
I would recommend
No, no. Trust. Not email. Where's the girl? No, you gave that one for them. Where is making another one with that? I don't know what the other side is. This could be a personal assistant. No. I don't doubt it. I know it. Yeah, yeah, not that. Yeah, she does see what's in money. You're not wrong. You watch. You guys split it? Huh? You guys all do it? Oh, she does. She still does sometimes. I try not to let her. So it's your fault. It's supposed to be down. She still pays. Like she charged that. It's not one of those. I mean, that's not personal. It's not personal. But she still pays. You and Josh, I'll take you some J-Box, get you a $1 copy. You'll be right. You see like how improvements go. Yeah. Like how garbage is. Here, order this time. Mistake. Oh, I assume like what means that they should be. I mean, kind of, because it won't even like switch back to math, like it won't.
Oh,
No.
well, go ahead, go on. I mean, looking up things.
That's what.
It's a big service.
Hey, no, hey, no way. And I'm not gonna go. But they say so for a beef to be 100% like versus say 100% beef, it all has to be 40%. So like Taco Bell literally has like 40% beef percentage, and I assume it's like more than what it is. I get the spicy potato tacos, they got those back, those are $5. And I get like the little tacos, and it's about never had a contract? Really? It's $5. Spicy potato tacos is really good too. I like this a lot. Oh, I like it. Okay, what kind of investigate? I mean, like, it's the Lord thing. Something the Lord. The Lord is. That's personal, but yes. Yeah, do fights every day. I just asked if you did have a girlfriend in person. If you don't take that, that's not good. No, Canes. Oh, Canes. They said Canes. How to get that? No, Canes pretty garbage. What? You like Canes? I don't think Canes are garbage. What? That's the best part. It's like a lot of what? That's what the stuff you did from Resident. Yeah. I'm gonna get something with one year. No, dude, I think Popeyes will play on the fire. I've been thinking about Popeyes, but I've never even had my chicken sandwiches. So good. I've never had chicken sandwiches. Oh, that's so good. I've heard good things. Some videos you see on the internet with Popeyes content. There's a restaurant where like specializes in chicken, ground chicken. Did you see the video where it's like Popeye versus Chick-fil-A workers and the Popeye workers try to fight you? I wish I did Chick-fil-A service like that. Bro, she was like my pleasure. I was like, Yes, they're receiving
So you've seen kind of like the technical difficulties we've run into in installing things. As I said, it takes some
I
time.
got back into the Mac part.
Yay. Okay. All right. Well, if you're back in the Mac part, we'll try and figure it out after class. That's really good. Yeah, so cool. We got it all running. One of the things that makes that hard is just that everybody runs into different things every time I do this. Is people run into different setups, and so it's just a matter of working through that. All right, so if I can have your attention back, I'm going to get back and resume in here, so we can start talking about SQL itself. Okay, so we've got Workbench up and running. Sometimes that comes in as a separate install, but it looks like for most of you it came in as one thing. So let's talk about how we create a database in SQL. Okay, so there's a few commands that you need to know. Okay, so I'm going to talk about 3 first, and then we're going to kind of try them in Workbench. Okay, so the first command you need to know is create schema, and then you put the name of the schema. Okay, this will create a database. We'll create a database with nothing in it. It won't have any tables. It won't have anything. It'll create a brand new schema. Okay, so we're going to end up putting our tables. Okay, that's the extent of this. That's basically the extent of this command. It can't create tables. You need another command to create the tables to create everything else. Okay, where you see here my schema name, that has to be a valid name. It has to be a valid identifier in the SQL world. Okay, and so one of the things you'll notice, you see how there's these tildes here at the beginning and the end? You see that? Okay, those are needed in MySQL. If you're using MySQL, that says that this is an identifier, like a variable name, not a keyword. Okay, sometimes you have to distinguish between the two. It's worth noting that every flavor of SQL disagrees on what character to use right there at the beginning and the end parts. Microsoft SQL, it's square brackets, and I think Postgres, it's single quotes. It's way different, right? But that's the one you have to use. And so does everybody know where to find that key on their keyboard? Where is that?
It's right under escape.
It's right under escape. Yeah, that's usually where you're going to find it. You're going to find it right up there with the tilde. Okay. If you've done any JavaScript work, it's the same one that we use for template strings. Okay. But that's a key that maybe most people don't use as commonly, but you do have to use that one. Okay. If you leave those off, it might work, depending on what name you choose. Okay. But I would recommend being in the habit of putting those on there. So let's say we're creating we're creating the example that we used yesterday, right? Dealing with courses and students and teachers. What should we call that schema? What would be a good name for that schema? Suggestions?
For the work we've done so far.
Yeah.
School database.
Okay, that's fine. School DB, school database, or you just call it school. Any of those are fine, right? So those are all perfectly acceptable names for your schemas. Okay. Now, one thing I'd ask you to do when you're creating these schema names, because I have to run them and test them, please put your student name in there. Okay. Because what I'm going to end up doing is I'm going to need to run all these scripts, and if you start with them having your student name in there, that helps me, because otherwise I have to go back and put your student name in there myself, and that's not a need. That takes a lot of work. So I really ask you say, hey, yours would be like school Evan Arnaz, is how I would say put that in there, right? And maybe separate it. Okay. Now I did put a poll up when we're talking about identifiers. I asked about table names, and this does apply for schemas as well. It really applies for those. There's really 4 different ways that you can do this. You can name these identifiers with uppercase using uppercase snake notation, which is where you have the underscores between words, or you can do it lowercase with snake notation. Okay, so you can do uppercase or lowercase with snake notation. You can do camel case or you can do Pascal case. Any of those 4 are perfectly valid in the SQL world. You can build a SQL database using any of those 4 naming conventions. But please, whichever one you pick, be consistent about it. Okay, that's the one thing I ask. Whichever one of those 4 you pick, let's be consistent about it. Okay, so in this one, let's say, okay, we're going to create it as school and something like that, but we'll kind of come back to here. I'll talk about that in a second. So once you've created that schema, the next thing you need to do is to write this command here. This is a separate command. So you're going to say use my schema name. Okay. So what this does, the use command says, let's make that database that schema the active schema. So any code that I write from then on out is going to be referencing that schema. Does that make sense? If you don't do this, then all the code remaining is going to go to either A, whatever database you had selected previously, which more than likely is going to be the wrong database, or B, you're going to have to put the MySQL name in the entire file on every single line of code you write. You don't want to do that. Does that make sense? So this one line of code saves you writing tons and tons of extra code. Okay. Please have those 2 things. If you're going to write a script to create a database, do that first. Create it and then use it. Cool. We'll see that in a second. I'll show you what that looks like in Workbench. Okay. The third command you need to know is I'm going to create a table. So the command here is create table, and then you name the table. And that's the basic part that you have to have that. You create the table and you name it. Okay. Between these parentheses, you can write all sorts of things. Okay. Between those parentheses, you define what columns it has. You define its primary key. You define its foreign keys. You can define unique constraints. You can define indexes. There's a lot of stuff you can put between those parentheses. Okay? So a lot of what we're going to be on the slide deck is from here on out is just talking about what we put in those parentheses. Okay? Because there's a lot, right? But that's kind of your starting point. So things to notice here, and this is where I want to talk about the naming conventions, is as we're naming these, you notice we had to name the schema, we had to name the database, we have to name the tables, we also have to name the columns. Okay? All 3 of those are cases where we've got identifiers. Okay? So I did a little poll. If you look on Perusal on this slide, I did a little poll and asking people, which of these would you pick? Okay? And let me just say that all 4 of these are valid decisions, right? I have seen all 4 of those in industry. Okay? depending on what company you work at, they will have probably already picked one of those choices. Okay? And so whatever the company picks, you need to follow the company's choice on it. Okay? Doesn't matter what your feelings are on it. If the company has chosen a particular naming convention, you need to follow that company's naming convention, not pick your own. Is that clear? Okay. So, but in here, outside of your company have already picked one for you, it doesn't matter which one you pick as long as you're consistent. Okay. So, thoughts? Everybody give me kind of a for or against for one of these options. We had some discussion on Perusal already, but I don't know that everybody's seen the discussion yet. Go for it.
I'm not a big fan of the all caps.
You what?
I'm not a big fan of the all caps.
Not a big fan of the all caps. Okay. Which one are you a fan of?
I wish there was a snake case, but with pastel or camel casing in it, so you could have capitalized letters.
Well, you don't want that because what each of these are defining is how you separate words, right? So snake case says separate each word with an underscore, okay? But then the choice is, do you have all the letters be uppercase or do you have all the letters be lowercase? You really, really don't want to combine camel case and snake case. It creates a mess. It looks really ugly if you mix those two together. Okay.
I thought just on Google, that kind of snake case might be easier to use on computer savvy, the word in general.
Okay.
So maybe just more easier for me to read.
Okay. Okay. So which snake case would you prefer, lowercase or uppercase?
Good.
Okay. So both of you said you kind of don't like uppercase snake case. Why? What turns you off about uppercase snake case?
I mean, when do you read words in uppercase, right? Most words are lowercase, and it comes natural to you. And when you see an uppercase letter, it's because it's a proper noun, or because it's the first word of a sentence. I don't know.
I was just thinking, like, I prefer to not have caps lock on.
Yes, actually, that's the best reason. The best reason for why not to use uppercase snake case is because it forces you to have caps lock on basically all the time. And then your code is screaming at you. Honestly, most SQL's code is screaming at you because if you talk to any kind of legacy programmer that's been doing SQL for any years, most of the times what they're doing, notice caps, capital keywords, capital data types, and capital names. They don't actually, most old school SQL developers don't use lowercase characters at all. They just pretend they don't exist. And that's kind of a legacy from, I think, dates back. I don't really know what caused that, but SQL's not the only one that has that. If you look at old Fortran and old Basic, they used a lot of uppercase letters instead of using lowercase letters. I don't know why that's the case, but that used to be the common thing, is to write a lot of your code in uppercase. Okay. And that's still, actually, I will say, the one that I see most often still is that one, uppercase snake case. I see most people, if you talk to anybody that's been in the industry for 10, 20 plus years, usually that's what they do, especially if they're a DBA or if they're really from that database space. That's usually what you see. And a lot of tutorials are that way too. Okay. You can do it all for the choice. So the biggest reason I don't really subscribe to that philosophy anymore is simply because, yes, I have to keep caps lock on to do that. And that's kind of a pain. Okay. What else? Any other thoughts? What about your programming language? Right? What rules did you follow in your C# course? Because you had some naming conventions, right? What were the rules that you followed? Camel case? Was it always camel case?
Always.
No, it wasn't.
It wasn't. You're right. Well, elaborate on that.
I kind of forgot, but I know, you call it, was it classes? It was like named different.
Yeah, classes were named different. Pascal, right? So the default in C Sharp, we generally write our classes in Pascal and our variables and such in camel case. And that's actually borrowed from Java. Java really kind of led the charge on that and Java said, okay, all of our classes will give them Pascal case and all of our methods and our fields and our local variables, our parameters, everything else, we'll give it camel case. And that way we know which is which, right? If we're looking at it, we know Pascal case means it's a class and camel case means it's a variable, which is helpful. It's actually helpful, okay? There's one reason though, camel case and Pascal case are largely not used by a lot of developers, okay, in the SQL world. Okay, there is one reason why that is. Most SQL developers do use one version of snake case or, okay? Here's the reason. Your identifier names in SQL are not case sensitive. Your identifier names in SQL are not case sensitive. So that means in the world of SQL, is the same as any other case. Regardless of what the case of the variable is, it doesn't matter, right? It's going to treat two identifiers that are the same as the same letters, regardless of whether they're lowercase or uppercase, it's going to treat them as the same thing, which can sometimes break your expectation when you're doing camel case and Pascal case, because it may look like these two things are different because you capitalize them differently, but in rare cases, in very, very rare cases, you end up with a case where you have two things that are named the same thing. They just look different depending on your capitalization. Does that make sense? So that's one reason why a lot of people don't use camel case and Pascal case. It's generally recommended against that because you don't have that problem if you do strictly snake case or strictly snake case, either lower or upper. You don't have to worry about the fact that the case is insensitive. Does that make sense? Cool.
This is kind of a stupid question, but why aren't they case sensitive?
Why aren't they case sensitive? How old is SQL?
It was introduced in 1995.
Like 1970. 1970, 71. We're talking about 50-year-old technology. If somebody changes that and says your identifiers are case sensitive, you're potentially breaking 50 years of tradition. 50 years of code. Nobody in their right mind's gonna really probably do that. So that's why, is because that is tradition. Because it dates back to the 70s, that's when we made that choice that it should be case insensitive. Does that make sense? In fact, that was the predominant thinking for a lot of languages. A lot of languages were case insensitive in the 70s. Some of those early languages were. That was pretty common. It's less common today, right? If you look at most modern programming languages, we expect our case or our variables to be case sensitive. We've kind of changed our expectation. So in JavaScript, we expect, and that's how it behaves, that two identifiers that have a different case are different variables, right? That's our expectation. But we don't have that expectation in SQL, right? We don't expect the student with an uppercase S to be different than a student that's all lowercase, right? We expect that to be the same table, okay? So it's mainly down to tradition. Does that make sense? Can I answer that? Okay. And so because of that tradition, these are not used as much camel case and Pascal case are a little bit more rare in the relational database world because of that. I don't have a problem with you using Pascal case and camel case, honestly. I think that that case in particular where things overlap is pretty rare. And in the grand scheme of things, it actually does make it easier to work with your code that you end up writing, whether it be in JavaScript, whether you're writing in C#, whether you're writing in Python. More than likely using camel case and Pascal casing is going to work better with whatever programming language you use. Okay? So there's that trade-off. I think it's pretty, at this point I'm thinking that, yeah, I'm on board with using those two things. So what I would do is what I would suggest to you is maybe a good thing to follow. There's a bunch of different choices you can make here. Not everybody makes the same choice, and that's okay. All I ask is you as a student, choose a set of rules and follow those set of rules. And those rules, you don't have to choose the same rules for every kind of identifier. Okay, so you can say your columns are going to follow one rule, your table is going to follow another rule, and you can follow another rule for your schema. I'm okay with that. Okay, but be consistent at each of those three levels. So one thing I might toss out there is a pretty good starting point is to say make your tables Pascal and make your columns camel. Because that follows what you're familiar with doing in C#. In C#, you said your classes were Pascal and your fields or your methods were camel. And so if you do that, then it will kind of be what you're familiar with when you get into actually working with it in your code. Does that make sense? So that's what I would suggest to you. It's probably going to be the one that you're going to have the easiest time once you start writing actual web applications. If you start with saying that the tables are Pascal and the columns are camel. But you don't have to do that. It's perfectly valid to say these are camel and those are also camel. That's perfectly fine. I have no problem with that if you want to say I'm just going to use camel case everywhere. I think that's the most recent project that I did. I just did camel case everywhere because it was easy. Cool? Okay. So let's talk about, let's actually get into using these commands. Okay. So I'm going to go back to Workbench. I'm going to close this tab here in the middle. Okay. And so remember that there's administration. Administrators is kind of where, if you're a DBA, actually DBAs spend most of their time on this side. If you're not a DBA, if you're a developer, you're going to spend most of your time over here. So jump over to schemas, okay? And what you should see on the left is that you have a Sequila database, you have a sys database, and you have a world database, okay? Does anybody not see those three databases? Does anybody not have those three databases? Sequila, sys, and world. Are you missing one? You just go over to schemas. You see administration, schemas. It's right here. Over on the left. It's just this tab. You only got sys? Okay. So if you only have sys, we'll have to go back and install Sequila and World because you're going to need those for the lab. Okay. Those are example databases. Okay. Now, of those three, so Sequila and World are examples. One of your first labs is actually going to have you do some SQL with the Sequila database. That system database is really critical. Okay, if you break the system database, you might as well uninstall MySQL, and reinstall it again. Okay, that system database is critical to MySQL working. It keeps track of all the databases you have and all the tables that you have and those kind of things. Okay, so be really careful that you don't do anything with the system database. It will update it itself automatically as you're working with things. Okay, you really want to be careful you don't accidentally use it. Am I clear? right? So don't accidentally create tables, don't actually delete it, don't actually delete tables within there. Really, really avoid working with system. Okay. So I want to create my own schema here, right? So let's say we do that. I'm going to go up to the top, and we're going to do this through SQL, the SQL commands we just talked about. So up in the top, you see create a new SQL tab. That's going to open up like this, okay? So what you're seeing in here, for me it says SQL file 4. SQL file 4. It may say SQL file 1 or whatnot for you, but this gives us a window to start writing SQL code, okay? Now, before I get too far, why don't we just go ahead and save this file so we can, as we're going, we can constantly save our work. So what I'm going to do is I'm going to go ahead and save it. Even though I haven't written any code yet, I'm going to go ahead and save the script. So I'm going to go File and Save the Script. And so maybe I'm just going to go into Documents, and we're going to call this the school. Use the right keyword. School.sql. Okay. So I'm going to save that there. And that means as I'm working through this, I can automatically just do Control S and it'll save anything at any point. Cool?
What did you create with
So it's this top left one. You see the SQL with the plus. So I created a new SQL script, and then I saved that SQL script. Okay. You can also use the Save button up here to save it on the tab itself. Okay. So what I'm going to do is I'm going to type in that command. So we're going to say create schema. And I want to say we're going to create schema school. And I'm going to use this. And write it like that. And then I want to use that same schema.
I think it's not case sensitive to keyword.
No, it's not. It's just like it's not case sensitive for your identifiers. It's actually not case sensitive for keywords either. Traditionally, we used to, the tradition in SQL has also been to make all your keywords uppercase. Part of that dates back to SQL is actually older than syntax typing. Is one thing that's worth knowing. SQL is actually older than syntax highlighting. So the original SQL developers didn't have that benefit of having parts of their code highlighted in different colors. So actually it was really common to use the casing to make it more apparent, right? If you think about writing stuff in Notepad, right? Writing stuff in Notepad, all the text is black. It's really hard to write things. So they would traditionally use the uppercasing to really call out the keywords, if that makes sense. So that's one thing that they just do, okay? I kind of have gotten in the habit now of writing all my keywords lowercase because it doesn't matter and it's actually just faster to write code that way. It's a lot slower to hold the shift key or put on caps lock and write all your code that way. So those are things to consider. So if I just run that script now, what I'm going to do, let me show you this. If I highlight the whole script, I'm going to then hit the lightning bolt. Okay, when you hit the lightning bolt, it's going to run all of the code that you have highlighted. Make sense? Okay. Now there's a little bit of a bug in Workbench. Which is apparent now, because I just told it to create a schema, and it says down here, right, you see this little green check mark, it says both of those commands ran, okay, but it's not here. Any guesses of what I need to do? Yeah, hit the refresh button. So I'm going to go up here, I'm going to hit refresh. There's my school database. And so you can see that it's in black, okay? The fact that it's in black says that is your active database. So right now my school database is my active database, okay? Now, just for grins, let's try to hit the execute button again. Okay. Now this time it didn't work. This time it tried to create that schema and says, nope, I can't do that because it's already there. Does that make sense?
Makes sense.
Okay. So if I try to write a script this way, I can only ever run it once. I mean, I could highlight bits and pieces of it and say just run part of the script and just run part of the script as I'm running it. But I may at some point want to, at least as I'm testing this is not a great thing to do with real world data, just so we're clear, but I may want to maybe delete the database, right? When you read the assignment, the first one from, I think you read it on Tuesday, remember that you learned about some commands in there. And I think they said that there were the verbs delete and drop. Do you remember hearing about those two verbs? Okay. So delete is actually strictly used for data in general. We only use delete when we're deleting rows, okay? For any other part of the schema that we're modifying, if we're using the schema, the correct verb is actually drop, okay? So if I want to get rid of a schema, I don't delete the schema, I drop the schema, okay? Drop means it's permanently gone. There's no way to get back to it. There's no backups, okay? So if you do this in a real-world database, you're going to lose everything, okay? We're okay with that right now because we're just getting started, okay? But this is something really dangerous. So what I'm going to do is I'm going to put at the top of the file, first line of the file, drop schema. And that is literally all it takes to lose all your data, just so we're clear with SQL. It's really easy to lose everything.
This allows us to have that create and use in one SQL file so that we can constantly execute.
Yeah, so you can constantly execute it. So if I do that, I can keep hitting execute and it's fine. It'll throw everything away and then recreate it. All good? Everybody kind of understand what I'm doing? Okay, now here's a problem. Okay, I'm going to refresh. And I'm going to actually just go straight up delete this here. So I can also just use the GUI to do this. So I'm going to say, let's drop that schema. Just say drop it now. Okay, so it's not there. Right, see, it's not there. Okay, I can refresh and it won't be there anymore. Let's try to run this script again. One thing worth noting, if you don't highlight anything, it will run the whole script. So that's one way you can get around this. If I try to run the script now, it fails. Because it can't drop the schema, because the schema doesn't exist. You see the problem? So it's like this game of cat and mouse. It's like, well, if I just have create, well, only works if it's not there. If I drop and then create, I'm assuming that it was already there. Okay? Huh? It's actually really easy. There's 2 words you can add. Drop if exists. And that says, I only want to drop the schema if it's there. And then if it's not there, it just says, okay, I won't do anything. And so it doesn't complain if it's not there. And that's all you need to get past it. Does that make sense for everybody? So that's kind of the easiest place to start if you're just trying to create your initial database. Just kind of starting your program with those 3 lines. You drop the schema, you create the schema, and you use the schema. And so if you do those 3 things first, you'll be starting with a nice, clean database. every time. Cool? Okay. Because here's what's going to happen. As you're writing and creating these schemas, you're going to make a lot of mistakes. I can guarantee you. And so that will help clean up after you every time so you can keep going and not get stuck. Cool? Okay. So that's what's going to be at the top of this file. Remember, just a reminder, by the way, comments in SQL start with a dash dash, at least in this version of SQL. Okay. Because that literally is losing all the data. And right now, you don't have any backups on your computer. So if you lose the whole database, I'm sorry, I can't help you. It's gone. So that's where that stands. Okay, so let's say we want to create a table, right? I showed you an example of the ERD that I created, right? Which table did I suggest that I maybe started with in creating that ERD? Do you remember which table it was? Where did I start with that ERD? Teacher, right? And so why would I want to start with teacher? Well, teacher can be there first. No other table has to be there in order for me to start adding teachers. Okay, so I'm going to create that table first. And let's kind of look at what that looks like. So I'm going to say create table. And I generally give myself some blank lines in here to kind of separate things out. So create table. And let's say this is the teacher table. In here, I want an ID. And I want that to be, for the moment, I'm just going to say, let's make that a big int. And we'll talk about data types in a minute. I want the given name. And that's going to be a varchar of some sort. And so I might say varchar 20. And the family name, varchar 20. So just like that, you can start creating tables. Okay? That gives me a teacher table. It's worth noting that that teacher table doesn't have any primary key if I create it like this. And another thing that's worth noting is that it allows all of those fields to be null. Okay? This does not put any sort of constraints on there that would prevent it from being null. Does that help? I see people squinting. So we have, for each of these columns, we've got the name of the column, we've got the data type of the column. I guess I'm still in the habit of putting these in as uppercase for some reason, but you can also put them in as lowercase as well. I've just done it for so many years as uppercase that my habits kind of become that. That's my instinct. So I can do that. Everybody good with that so far? Now, real quickly, if I want to make this a primary key, you can just literally add those words. Primary key to the end. It's now the primary. We usually have a little bit more to it than that, and we'll talk about some of those more things that we want to add. But that's the simplest way to define a primary key. Just add the word primary key at the end. There are other ways to write this. Okay, let's just be clear. There are other ways to write this, but this is the easy way. Okay, it works most of the time. Not all the time, but works most of the time. Okay, so that will make that a primary key. And I can now go back to my slides and we'll kind of talk about some of the syntax. Okay, so you kind of started to see how to use workbench. Okay. I'm going to talk a little bit about theory before I set you loose on kind of creating the rest of that schema. Okay. So in MySQL, there's a few different data types. Okay, and these data types, while there is some standardization between different versions of SQL, most versions of SQL disagree. Okay, most versions of SQL do not agree on how the data types behave. So if you're learning a new version of SQL, make sure you read up on the data types because they will be different if you're using anything else. SQLite is one of those that's very weird about how it treats data types. So let's talk with integers. Integers is pretty simple. There are tiny ints, small ints, and big ints. Okay. Your regular ints are 4 bytes in size. That means there's 32 bits. Your big ints are 8 bytes in size, meaning 64. So you've got 64, 32, 16, and 8, right? That's how they correspond. So if you're thinking about this in terms of C#, this would be a byte, a short, an int, and a long, which is really helpful to just kind of remember them as such. Okay. So tiny int, small int, and big int. Generally speaking, the advice is use the smallest one you can. Use the smallest one you can. One of the things you have to be careful, though, in terms of primary keys, okay? In terms of primary keys, once you decide on the data type for a primary key, it is virtually impossible to change it. It is practically impossible to change it, okay? So, don't choose a data type for your primary key that you're ever going to want to change. Does that make sense? Okay. So one of the things that means, let's talk about the small case. If I have a tiny int, that goes from 0 to 255. Okay. So that means if I have a table that I know will always have less than 200, or sorry, it goes from 1 to 255, because these numbers generally start at 1. That means I only have space for 255 rows in that table, ever, period. I'm using that for the primary key. Does that make sense? What's something where that might work? What's a case where you know that you might never have more than that?
Say your table has all of the RGB codes.
What do you mean all the RGB codes?
For degrees of red, and 0 to 255, and they would match exactly.
Okay. But that's only for red. It's only for one channel,
Yeah,
right? Because remember, colors are generally represented as red, green, blue, which means that colors generally take up at least 24 bits. And in reality, they actually usually take up 32 bits because you also have to consider opacity. So a lot of times, colors actually need a whole integer bit. Okay. But that's a different story anyway, right? What we're really talking about is tables, right? Think about these as entities, right? That's just a scalar value, right? What I'm asking about is what is something that you're only going to have a small number of and never going to have more of. There are actually a lot of those cases. Actually pretty common.
Like age.
Okay, age, yeah. But that would probably not be something I'd use as a primary key. Okay. Because we're talking in terms of a primary key is what I'm trying to talk about. But yeah, age is one of those things. A channel of a color might be. But if I'm thinking about primary keys, in the context of primary keys, how many states are there in the U.S.?
Currently there are 50.
Currently there are 50. What's the likelihood that there's more than 255?
Slim.
So I could safely say give every state a number, and it would probably fit in a byte, and I wouldn't ever have to worry about it. Okay, so that would be a safe case to do that. If I say, hey, I've got a drop down of that. Similarly, let's think about auto manufacturers, right? If I was going to say auto manufacturers, what's the likelihood that I have more than 255 companies making cars? Probably pretty low. I mean, there's a good number of companies, but there's probably not 200 of them, right? So I could say, okay, well, those kind of things that I put in a drop-down, oftentimes that's the case. If it's something where you're going to say, hey, this is some selections, some things I'm going to put in a drop-down, and I know ahead of time what they're going to be, it's probably safe to use a tiny int for those cases. Does that make sense? If you know all the possibilities ahead of time, you can usually say things like that. Evan, are you training? Okay. So that kind of makes sense. But most of the time, I think historically a lot of people have gravitated towards an integer as the primary key because it's the easiest one to grab and it's just basically the shortest one to write. It's the fewest characters. I would strongly advise you, if you're going to use a number at all for a primary key, which I wouldn't advise in general, is not using a number. I would not advise using a primary number for a primary key, but we'll talk about that in a minute. At least use a big integer for most things.
You said not use a number for.
Yeah. In general, for a primary key, a number is a bad choice. But if you are going to pick a number, then pick big int in most cases. If you don't know how many things there are going to be, assume that the 32 bits is not big enough. Okay, you'd be surprised how big some things can get. There are databases out there where there are tables that have more rows than fit in an integer. There are databases like that. Okay, it takes a few years usually to get there, but they do exist. You know, and we're honestly, you may be building a database that needs to last for 20 years. So you have to make that consideration. So it's usually a safe bet if you don't know and you're going to use an integer, use at least a big integer. Okay. Rather than reaching for integer, go ahead and reach for a big integer. It will be worth it in the long run. It may take up twice as much space, but you'll never have to change it. I can guarantee you that. If it's a big integer, there's enough data there. In fact, big integer is big enough that it can hold a number for, I think it's, if I remember right, the biggest number in big int is bigger than the number of atoms in the Earth. Kind of thing. Cool. So it's basically safe until we leave planet Earth.
That's big int.
That's big int. That's not int, that's big int. Okay? Int is much smaller than that. Int is not big enough to hold the number. Int is not big enough to hold all of the devices that we have on the internet right now. Okay, that's the distinction. Int is not big enough to hold every device that we have right now. But big int is enough to hold all the atoms. Okay, that's where we're defining the difference. Cool. Cool. Okay, so that's what I would say is for data you can pick one of these shorter ones, but if you're picking a primary key, just go straight up to the big int unless you know for sure that it's never going to be bigger than that, right? Never going to be bigger than small ones. Next thing, let's talk about numbers. There's some other kinds of numbers. But generally speaking, the only one we use in SQL when we're dealing with floating point numbers is decimal. Generally speaking, that's the only one you're going to need. Okay, so specifically if we're dealing with money, American currency, you only go down to cents, right? You only need 2 digits after the decimal place. And actually most currencies, it's not always, in general, it's not necessarily just 2, but every currency other than Bitcoin has a lower limit, right? So we can usually safely assume that there's some lower number of decimal places anywhere in the middle. One of the nice things about this decimal data type is it actually stores it in decimal. it doesn't convert it to binary. It's not saving it as a binary number. It's actually saving it as a decimal number, which is really important when you're dealing with money. Okay, it means that it eliminates a lot of rounding. Okay. So decimal, you'll notice that it has this parentheses here, because anytime you use a decimal as a data type, you have to specify how big of a decimal is it. Okay, so it requires two numbers. You can see they're called precision and they're called scale. Okay, so let's talk about what those numbers are. So if I'm talking about a number here, 0012.34, right? How many digits does that number have in?
6.
It has 6, right? Counting the leading zeros. Okay, so that's got 6 digits. That as a whole is the precision. So that's got a precision of 6. Okay. It's on the other side, it's got a scale of 2, because there's 2 digits after the decimal point. So the precision is how many total digits does it have. Scale is how many of those digits are after the decimal point. Okay. And so if I say the biggest, my monetary, like I've got stuff on my store, and the biggest amount of currency that I'm ever going to deal with is like thousands of dollars, well then I only need 6 digits, and 2 of those are after the decimal point. If I'm dealing with millions of dollars, right, well then that's a different story. I'm going to need how many digits? If I've got $1 million potentially.
At least 9.
At least 9? What were you going to say, Tom?
Well, I was also going to say 9 million.
Okay, 9 million? That sounds right, right? That sounds right. So the trick here is, remember, with one of the things we're trying to do with SQL and relational databases is minimize how much space it uses, and to minimize how much space it uses, we need to cut down on the number of digits that we have. And so that first number, the precision, the higher that is, the more space it takes up. So we want to have it big enough that we can hold everything that we need to do, but we also don't ever want to have to change it. So we need to build in some padding in there so we don't have to change it in the future. So that's how you're going to deal with decimal numbers. Okay. So like if I'm dealing with grades usually have a decimal point and have partial points. Then you've got dates and times and date times. A date in SQL is just a date. That's all it is. A time in SQL is just time. Date time is those two put together in one field. Okay. And so that's how those work. You can kind of see the format that MySQL specifically expects. So year, month, day, hour, minute, second. Year, month, day, hour, minute, second. In that order all the time. And you'll notice it's 0 padded. You know that there's colons with the time, there's dashes with the date. That's important if you're trying to get dates and times into. Dealing with strings. There is no string data type in any version of SQL. Not really. Basically, now SQLite's kind of a weird exception in that basically everything's a string in SQLite, but that's a whole other story. Char, varchar, and text. Okay, so varchar, your char data type says this can hold a string of a fixed length. A string of a fixed length. It always has to be the same length. Okay? So the most common case where that occurs is something that looks like this. Does that look familiar to anybody? Zip code, right? Zip code, at least in theory, always has 5 digits. Or in reality, it has 10 or 9, depending on how you write it. So you could say 63301-1234, right? Fixed says that your thing always has to be that. So I could say if I'm dealing with zip codes, I could say this would be a car 10, or this would be a car 5. Okay, so that occurs in places where you expect that. Make sense? Okay. If I'm talking about a state code, so something like this, 2-letter state code. Well, okay, so that's a car 2. Make sense? So but it has to be something where everything that's always in that table is always going to be the same length. Okay. You can't have some rows in that table have one length and other rows in the table have a different length. They always have to be the same. Okay. Varchar is a little bit different. Varchar says it can have a variable number of characters up to the length. So if I say varchar 20, that can have anywhere from 0 characters to 20 characters, but never more than 1. Make sense? So varchar gives you a little bit more flexibility. We tend to use varchar a lot more than we use car. Okay? And then finally, this last one, text. Okay? Text lets you have a string of any length you want. Which I kind of said we don't really have a string. Okay? Because we don't really have a string. So text lets you have as long as you want it. It generally does have an upper limit, but that upper limit is usually far enough up that you don't have to worry about it. In fact, you can usually put an entire blog article in a text column, okay, and be okay with it. The difference is that there's a lot of things in SQL that don't work with text columns. Because the way that they work is kind of different. All of these other data types that we talked about so far, they're stored together. You pack together the row, and it's stored in one place. The text is actually not stored as part of the row. If you have a text column that's actually stored, basically you can think of it being stored in a separate file. It's not actually stored in the table itself. So it comes with some performance costs, but it also means that some features aren't supported when you're dealing with text columns. Okay? So that's the thing you have to recognize. I do still find places where that's useful. It's just a question of, it's really hard to figure out when to use that and when not to yourself. But it is available out there. Last ones. There's a binary and there's a blob. Okay? A binary n, is basically a car in. It's like a car in. Car in says I can have this many characters. Binary n says I can have this many bytes. Okay. So binary 16 means I can have 16 bytes of data in that column. So it's used for storing binary data, not textual data. Does that make sense? So it's for binary data. That's good for things like passwords, because you want to hash your passwords. You want to keep them basically encrypted. You don't want to store your passwords in plain text. So we store passwords in the database as binary. Because we actually, as it turns out, the algorithms that we use for working with passwords always give us the same length of binary array. And so I know that the length of that array is going to be, so I can say binary n. So if I know it's going to come out as 200 bytes, I can put binary 200. Cool. So that's usually what we use for passwords. Last one being blob. Blob is, here's binary data. It's just like text, and it's stored outside of the actual table itself. But it can be any length. A blob can be any variable length of binary data. Some people have used blob as a way to store an entire file in your database. That sometimes happens. Some people do store entire images using a blob type column. I would not recommend doing that. It's better to actually keep your images on a file system, because databases don't work very well with image and other kinds of files, PDFs and things like that. It doesn't either as well. But blob allows you to put binary data, arbitrary binary data in there if you need to for some reason.
So blob represents literally a blob code.
blob of data. Blob of data. Yeah. It's a blob of data, just an array of bytes. Okay. But the thing is, like, the database have absolutely zero optimizations for working with blobs, because it doesn't know anything about it. It doesn't know what to do with it. It can't help you. It can't optimize with it. So in fact, blobs can really slow down your database and make it much slower by adding them in there. So you usually want to avoid blob types where we can. Okay? Because they have a really big negative impact on most SQL databases. Cool. Those are all the data types you need to know about. That's the whole list. There are some other data types that exist, but those are the only ones you need to use. Okay. One of the notable exceptions on there, there's no Boolean data type. Do you see that? Because there aren't any SQL databases that handle Booleans in a sensical way. They all treat them differently. They all have weird quirks. It's better not to use a Boolean data type. So what do you use instead? Use a tiny int, and you say it's 0, it's false. Anything else is true. Simple as that. And that works in any database. As you can say, hey, I'm just going to use a tiny int, and 0 is false, anything else is true, and we're done. And that works regardless of the database behind it. So, talking about keys, every table, remember, needs to have a primary key. That's the expectation. Primary keys must be fixed, unique, and not null. We talked about this yesterday. Okay? Acronym being fun. Just that's a reminder. So there's a few different ways to define a primary key as far as MySQL is concerned. Okay? So one way I can define a primary key, and this is the one that you're going to see most common if you work with any MySQL databases. You ever work with a WordPress database, you're going to see this sort of thing all over the place. Right? So we have an ID. I have a data type. Here I'm using big int, because as I said, you usually want to get a kind of plan ahead. The word primary key, it's a keyword, and an auto increment. Okay? Auto increment's a special word. Okay? Auto increment can only be used in combination with primary keys. That's it. You can't use them with a foreign key. You can only use them with primary keys, and you only use them for one column in that table. Only one column in the table can be auto increment. Okay? Auto increment says, I want to automatically assign a number here, and that will go up as I assign, as I create more records. Automatically increment it. So the first record will come in with an ID of 1. The next one will be 2, and 3, and 4, and 5, and 6. That's what auto increment does. It makes that happen. Cool? Without that, you have to specify the ID every time you insert it. If you don't put the word auto increment in there, you have to tell it the number that you want to use every time. Okay? And sometimes that's good. Sometimes you want to, sometimes you're in situations where you know those numbers and you can do that better in your code, and you don't want the database to automate it. But when you do, that's how you set that up. Cool? Okay. Other versions of SQL do that a little bit differently, but that's how MySQL sets it up, is that keyword auto increment. Another way to define primary keys is to use something called a GUID or a UUID. That's an acronym for Globally Unique Identifier or Universally Unique Identifier. Okay, and this is what a UUID might look like. Okay, see a bunch of numbers, bunch of numbers, bunch of numbers, bunch of numbers separated by dashes, and there's some grouping in there. Okay, I want to get into the grouping, but it's basically this long series of numbers. Benefit of a UUID is that it's randomly generated. Okay, so you just say, hey, I want a new one. It'll come up with a random one, and then you use it. it's long enough and rare enough that actually it's very unlikely for you to pick the same UUID twice. Remember how I said 64 bytes is big enough to hold a number for every atom in the earth? Okay, these are 16 bytes long. These are 16 bytes long. Not just 8 bytes long, they're 16 bytes long. Likelihood of collision is astronomically low. It can happen, but it's very unlikely. And so we use these in the context of saying, well, we can just pretend that collisions never happen, almost. It's basically at that point you can say, no, let's just pretend they don't exist. And you do have to kind of treat them as that, but it's very unlikely that they will. And so I can use that as my primary key. And so the correct data type here is binary 16. That's my primary key. There's a lot of security benefits to doing this. I think we're kind of short on time, but the part of what this comes in is it's really easy to guess numbers. Because if I'm using numbers, I can just try all the numbers. 1, 2, 3, 4, 5, 6. And I can potentially exploit your website and get into things that I'm not supposed to by just guessing numbers again and again and again and again. That's an actual security vulnerability, believe it. It's called forced navigation. So that's a risk that you run into if you're using a number, right? Using a big int even for your primary key. I can guess them. I can also look at it and say, hey, I just created a user account. My user account has an ID of 5,000. Do I know something about your system from knowing that my user ID is 5,000? Yeah, I do. Well, I know you probably have 5,000 users. If I just create an account and it just got user ID 5,000, I know that your system probably has 5,000 users on it. Some data I might not want to leak out. Or let's say create an order, and I find out that order is order 5,000. I know you now have 5,000 orders.
I've seen that before.
Yeah. So that could be an issue. That could be an issue to have that information disclosed, and that can happen very easily. That's especially nefarious when it's a company like John Deere, which doesn't have a lot of customers, but hey, knowing how many customers or how many tractors are on in the market would be a very valuable thing, right? Or if you're working with any company that makes some very high dollar equipment, knowing how many things of those you've made or sold is a really valuable thing. It would be really nice to know how many users are there on the Epic Store, how many users are on Steam. Well, and if I can play this game, I can say I'll create an account today, and I'll create an account in a week, and I know how many accounts have been created in that week. Because I can just take the difference between those two. You see the problem?
So what exactly can one do with that, with information that specific?
I can, for one, I could go back and try all those numbers and try to hack all their accounts. Or I could see how if I'm a competitor, I kind of want to know how they're doing and things like that. There's a lot of reasons why you might want to know that, suffice to say. So, and it's something you really don't generally want to leak. So these are still something. There are a lot of big companies that are still using this, and they're okay with it, and they've accepted the risk. I am generally not okay with that risk because there's not really a way around either of those two problems. There's not a way around forced navigation, and there's not really a way around that kind of information if you're doing it. So I usually do this. I would suggest for the lab you're going to do the group exercise here. I would recommend sticking with auto increment. That's okay. But if you're going to do a real world project, use this. Cool. And in fact,
How do you get that generated?
I think that's maybe later on this slide.
Okay.
On this slide. So I would recommend using that. In fact, when we talk about Mongo, Mongo only supports this. If you're doing Mongos, then if you're doing Mongo, that's basically what they suggest you do. You go ahead and use GUIDs, and don't. Mongo doesn't even have an auto increment type because it's such an issue. Another way that you can do things is you can have that primary key be externally generated. Right? Maybe that primary key isn't generated by anything in your code. So for instance, here with zip codes, right? Zip codes aren't defined in my application. They're defined by the Postal Service, right? But I know that I could potentially use those as a primary key here. And just say, hey, I've got my zip codes table. Primary key is the zip code, the 5-digit code. And with that, I can refer to the city and state. That's fine. Because that's how the Postal Service designed them to be used, right? A zip code represents a city and state. Kind of geographic region. So that would be okay, right? There are cases like that where you can just say, hey, I have this number, this thing in the real world, and I'm going to use that as the primary key. Perfectly fine. Notice I didn't add the word auto increment onto it, though.
Yeah,
that would not work. Yeah. Also notice when I'm using a GUID, I didn't put auto increment on that one either. Okay. So they don't always go together. Okay. Let's talk about foreign keys. Remember, foreign key is a way to represent the relationship. And so the many side of this is where the foreign keys come in. So the teacher ID was over the course because, you know, the course is taught by the teacher. Right? So it's over on the many sides of the relationship. So the foreign key is going to appear in the course. It wouldn't appear in the teacher. Okay? So if I'm creating two tables here, right, so let's say I create zip codes and addresses. And in the address, I have a zip code. I could say, okay, this zip code is a foreign key to the zip codes table. Does that make sense? It's a reference into the zip codes table. So I say, okay, we're going to take that zip code, references this foreign key, says here's the table, here's the name of the column here. So this is the column in this table. References the other table and the name of the column in the other table. In this case, this is kind of a simple case because I named it zip here and I've also named it zip there. But more than likely, you're going to find that I have different names. So for instance, if you looked at the schema that I created, in the course table, I just called it the ID. In the course student table, I called it the course ID. So oftentimes, your name here and your name there won't match up. Cool? But that's how you know which is which. This is the name of the local table. This is the name of the foreign table. It's also worth noting you can use that same syntax to connect more than one column. Okay, if I have multiple columns, it would be like zip, comma, state, or zip, comma, state, kind of like that. So that's the way I would treat that. And remember, I have that assignment grade, which refers to the course student table. I've got two columns that are foreign. That's how I would do that. Okay. Another thing in here, we talk about indexes. Indexes are a way to make our queries and our accesses to the database faster. Okay, they are not strictly required. You can make a database without indexes, but it will be a very slow database. Be very, very slow. So we kind of talked about this idea of a card catalog. Card catalog is kind of where those indexes fit in. It's a way that you can, it's a separate structures, kind of separate from the table. You can go into it and find the data quickly. Okay, I want to get into the theory of all of that, but just know that the indexes are really important. Okay, And so in general, they make reading the data very fast, but they do come at a little bit of cost when you're writing data. That's the trade-off that you need to understand. That's the main trade-off. They cost a little bit when you write data, but they make it much, much faster when you read data. Okay? And in general, if I don't have an index and I say I want to go get the record that has zip code 63301, I have to look at every row in the table. But if I have an index for zip code, I can go just directly to all of the records that are 63301, and I skip all the other records. So it's really, really fast. Cool? Really, really fast. We're talking about if you have 1 million records and only 10 of them have that zip code, I only have to basically look at those 10. It's a huge performance factor. One general suggestion, anytime you have a foreign key, you should also add an index. It's really essential to make that foreign key fast. And in fact, you should put an index on both sides of it. You should index the thing here and the thing there. Now that's not true if it's a primary key. Primary key is automatically an index. You don't need to create an index for anything that's already a primary key, just so we're clear. Primary keys effectively function as an index. Any columns that you're going to filter or sort by frequently need to get an index. So again, with this one, I'm saying, well, these addresses, I'm probably going to refer to them by zip codes pretty often. So zip code would be a good thing. I probably might want to look them up by street address pretty often. So let's put an index on there for street address, right? So part of putting indexes in there is understanding how you're going to use the data, right? You have to kind of understand what queries you're going to run, okay? So we haven't talked about all those queries yet, so we need to get into that. But that's kind of where they exist. Cool? Another thing, defaults, okay? So default provides a way to say if I try to insert a record, and this only works on insert, doesn't work on any other operation. When I insert data into that table, if I don't specify a value, then use this value instead. So it's especially useful for things where I may be adding a column to a table. Then I want to specify what the default should be for all the data that's already there. Okay. So some examples here, I might say for the street address, well, the default is empty string. For the zip code, the default is empty string. For order count, I might say by default they have 0 orders. Or the created on date, let's say when this address was created, we're going to default that to now, the current date and time. So if I don't specify when it was created, it will automatically pre-populate it with now. Make sense? Okay, so now you asked about the GUID. Here's the magic sauce. So if I want to use a GUID, here's what you have to add in. You say that the default is this expression. This expression generates a GUID. So you say, call the UUID function in MySQL. The UUID function actually generates the UUID as a string. So we'll generate a new UUID, but make it as a string. UUID to binary takes it from a string to a binary thing, which makes it take up less space. So rather than being much larger than a binary 16, that gets it down to be binary 16. Does that make sense? That unfortunately is what you have to write if you want to use GUIDs in MySQL. There's not a shorthand to that. Cool. And that's part of why I'm okay with you just using auto increment if you want that. But that's what you would have to do. I do mention here it can be a literal or an expression. These middle cases would be literals. This default now, default binary, those two cases are expression cases. In the expression cases, you're allowed to use these functions, these SQL functions, and you're allowed to use literal values. You're allowed to use Operators, one thing you can't use is reference to columns. I can't refer to any of the rows or the data that's in the database in coming up with this default. Does that make sense? That's not allowed. So I can't base it on data that's already there. If I'm trying to make a default for a full name, I can't default that to first name plus last name. I can't do that. Another thing that we can do here, we can mark columns as unique or groups of columns as unique. So here I might say, well, the street address has to be unique. I don't want any addresses in here that have the same street address. And so that would prevent that. Cool? And say, hey, I don't want that. I might do that oftentimes for, if we're thinking about assignments, well, I don't want any assignments with the same name. So I might make name of the assignment unique. Okay. Unique can also be applied to a combination of columns. So here I'm saying has to be unique is the given name of the family. I can't have two people, two rows with the same given name of the family. Obviously, that doesn't represent the real world because that happens all the time. But that's how you represent that. Make sense? Cool. So that's unique. You can do it with one column or multiple columns. You can also say whether or not a column is allowed to be null. If you don't specify, the default is that every column allows null, except for, of course, the primary key, because primary key can't be null. But other columns in here, so I'm going to say street address, well, maybe I want to make that required. I don't want that to be left blank. I can say not null. So not null, adding that in there says that this thing is required. You can't leave it out. That is what we would say maybe a constraint on the database, on the data. And finally, there's another kind of constraint that you can add. These are a little bit more rare, but they're more general. A check constraint says I want the table, every row in the table, to pass this expression. I want this to be true for every row anytime you change the data. Whether you're inserting data, whether you're updating data, it needs to stay the same. Okay, these things need to be reflected. So for instance, some check constraints that I might put in here, I could say that your balance has to always be greater than or equal to 0. I'd say, I don't want your balance to ever go negative, and that would stop you from being able to enter a negative value for a balance. Or you might say, hey, I'm doing a credit card transaction. Maybe I don't want to have a negative value for that transaction. I could do that as well. INCR is a function that says this character, the string, needs to occur somewhere in another string. So here I'm saying that the email must contain an @ sign. And so that returns an index of where that's at. And so I say as long as that's the first index in a string is actually 1 in the SQL world. They start with 1, they don't start with 0. If it's 1 or greater, okay, then I know that the @ sign is somewhere in the middle of the string. Might be at the end, but at least it's not the first character, and at least there is 1. Because if there wasn't 1, it would return, I think, -1 or 0. That makes sense? So that's a check to make sure that your emails have an @ sign. Or here I'm saying, okay, I want to check that the full name is given name plus a empty string plus family name. Concatenation, concat, just concatenates these strings together. Okay, you kind of think about it as plus as you're familiar with in JavaScript or C#. So given name plus family name is equal to full name. SQL's kind of weird in here. A single equal sign, single equal sign, generally in programming means you're doing assignments. Doesn't mean that in SQL. Unfortunately, it's not even all the ways the case. In the world of SQL, sometimes a single equals, sometimes it means assignment, sometimes it means comparison, depending on context. It can actually be both in SQL. But generally speaking, most cases, a single equals is comparison. Okay. Questions? So check constraints are really flexible. There's things to consider. So that puts us at the end here. Now we've kind of talked about some of the things that you can do to design your database and to define those. You know, a lot of that goes into defining the constraints around the database, about defining what's valid data and what's invalid data. What I want you to do is work together to kind of take the ERDs that you have and turn them into an actual schema.